only mode.
On behalf of RBCS, welcome to today's webinar on how 2 bug metrics can reveal millions of dollars in process improvement opportunities. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their testing and quality assurance practices. I'm the author of many books on software testing, working on numbers 12 and 13 right now, in fact, as well as being the past president of the ISTQB. Attendance at today's webinar earns PMI PDUs. Thank you, Vicki Sasser, for reviewing the materials for PDU status and for making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. If you have any questions during the course of the webinar, you may submit them throughout the presentation via your webinar interface, but please note that they are answered only at the end. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not-just-for-profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com. So, here we have a Dalmatian. Everybody agree? See the Dalmatian there? Well, but notice it's not really filled in. Your brain is doing something there called closure. So one of the metrics we're going to look at has to do with closure, though not in the sense of what your brain is doing with the Dalmatian. Next to the Dalmatian, we see somebody up to their neck in sand. I couldn't find a graphic of somebody up to their neck in bugs. This person has a sand backlog. We're going to look at bug backlog. These are 2 very important and underused metrics that can help you find lots and lots and lots of waste and opportunities to make your processes better. Let me show you how. So we do a fair amount of assessments, and unlike some organizations that do assessments that are all wrapped around a maturity model and they're just like yes/no questions, do you do this, do you do that, and if you check enough boxes you get to be at some particular maturity level, we think that's kind of artificial. Rather than looking at maturity levels, what we want to look at is how's your process working. So we look at process metrics, process health metrics. And in any typical assessment, I will find in excess of $1 million in process improvement opportunities. Pretty much guaranteed. Might be willing to even make that a guarantee in the future because it's relatively easy to do. And I'm going to show you 2 very simple bug metrics that will highlight opportunities to make big improvements. The first is bug backlog, and the second is closure period. Now, you might say, oh, but these metrics, they must be very hard to capture. They must involve lots of data. Nope. 2 simple facts for every bug. When was it opened? When was it resolved? That's all you need. We could even do this in a spreadsheet if you wanted to, though that's not the smart way to track bugs. But that is all you need. And once you have those 2 facts for each bug, you can use a spreadsheet, which you can download from our website if you'd like. And it'll allow you to create these 2 graphical displays of both of these metrics that I'm going to show you, and it's a good chance that you would find millions of dollars in process improvement opportunities. So, start by explaining bug backlog. So on any given day, we can calculate the bug backlog as the total number of unresolved bugs. That's what I mean by backlog. Some people talk about pending bugs or bugs in process, or bugs under assessment, or there's different names that you might use for this, but I'm going to talk about unresolved bugs. And what I mean by resolved is that the bug that was reported has been closed, so it is confirmed as fixed, or it's resolved in the sense it's deferred. We're not going to do it in this release, and I don't mean next iteration. I mean it's not this release. It's not going to get fixed in this release. It's been accepted as a permanent restriction, or it's been canceled because it's not actually a problem. It's a false positive, or it is a problem, but it's a duplicate of a previously reported problem. So this isn't a unique, valid bug report. So basically, any bug report that is submitted and has not yet gone into one of those 4 states of resolution that I mentioned there is going to be unresolved. Okay, so hopefully that's pretty clear. Now, I'm going to show you just a sort of a raw or all-inclusive way of using this metric. It's also possible to do this by severities if you want, so you can focus on the more important bugs, like maybe you say, you know, Sev 1 and Sev 2 are the important bugs, so I want to just focus on bug backlog for the severities 1 and 2 bugs, and that's fine. You can do that. If you want to show this in a tabular fashion, you can, and provide more detail. So breakdown of backlog by risk categories, by functional area, by quality characteristic, by a subsystem if you've got your bugs classified by the affected subsystem. So you can get more detail that way, but what you lose if you show it in a tabular fashion is where are we with respect to where we've been and where we want to be. So a graphical view, which is what I'm going to show you, will allow you to see trends over time. Now, I'm not saying, you don't have to pick one or the other. You can use both. So here's an example. Some of you may have seen this before, this particular graph. Let me get the spotlight up. This chart is sometimes referred to as an open-close chart or a found-fixed chart, reported resolved chart. It goes by different names. So it's a trend chart. You can see it's a trend chart because the x-axis down here is dates. For those of you outside of North America, remember we do month and day, not day, month. So that might look weird to you. So this shows our entire planned test execution period, which for this project is 6-ish months, 5, 6 months. We have a prediction of the total number of bugs that will be found. You might be wondering, how did he do that? Well, that's a topic for another webinar, I guess. Assume that I have predicted that. And so there are 2 data sets that are graphed against this axis here, which ranges from 0 to 2,500. 3 data sets graphed against this axis here that ranges from 0 to 250, or exactly 1/10 of this axis over here. So the red and the green data sets are the total number reported and the total number resolved. Those are graphed over against this axis here. So what we see is that we're a little more than halfway through, a little less than halfway through, I guess, of our test execution period. And we found a little bit more than half of the bugs we expect to find because we predicted 2,000, and it looks like we're at 1,100, I would guess, from this. So we'll probably continue on and end up a little bit above. Now, you look at the green line. The green line is the total number of defects resolved, and you might say, well, it appears to be tracking. But let's zoom in a little closer, which is what the data sets graphed against this axis allow me to do. So there's the plus, which is the average number of bugs resolved in the week. And basically what you do is you add up the number of bug reports resolved on each day and divide it by 7. That's the average for the week. So it looks like this last week we were running at about 40-ish, a little above 40. And then the minus is the average reported. So that's just the number of new bugs that were reported, totaled up for the week, divided by 7. And that was running in the 20-ish, 25-ish. Now, so this week was a good week. The plus was above the minus, so the backlog went down. But we're also showing the backlog, and you can see that the minuses have been above the pluses for most of this project, which means the backlog has been steadily getting bigger. Now, the backlog is the red line minus the green line on any given day. It's the number reported minus the number resolved. So if I add up the backlog for each day in the week and divide by 7, that's the average backlog for that week, which is shown as the yellow or orange asterisks. And as you can see, this has gotten very, very badly out of control. It shot up immediately, shot up to 75 in the course of the first 4 weeks of test execution, and then took a sharp curve upward from there and shot up in a almost parabolic kind of curve here to about 200, and then at that point it's starting slowly starting to come back down. Now it seems to have accelerated in its downward pace here, which makes sense because over the last couple weeks we've had the plus above the minus, and last week the plus was further above the minus than it ever had been before, so it was a significant dip in the backlog. But you see how this chart makes visible where we are on the backlog, and this to me is not good. Really, anything over 50 is the point where I start to get concerned, and then it gets up here in the couple hundreds range, and that imposes some very, very serious inefficiencies. One example of an inefficiency associated with backlog is a tendency for organizations with large backlogs to force the testers to check again whether a bug exists after reporting it. So the line that you'll hear is, well, we've made a lot of changes since you've reported that bug. Would you mind checking to see if it's still there? In other words, please go spend anywhere from an hour to 2 or 3 hours rerunning the test that you ran before that surfaced the bug. Where's the value in that? Where's the positive return on investment for that? That's complete rework. It's total. It is waste. It's rework and waste. So that's one thing that happens. Another thing that happens is that bug reports do indeed get stale. It is not an illegitimate request for the developer to say, hey, can you check? Because what often happens is that the behavior does indeed change, and the bug report, the steps that reproduced the failure before may not reproduce the failure exactly now. So it's not that developers, well, usually developers aren't asking you, can you go make sure that it still happens, to be mean. Sometimes they're asking out of false hope that the bug got fixed by magic. But mostly it is a legitimate request of, hey, I'm not convinced that it's still going to do that. Now you might say, well, if it's a legitimate request, I mean, weren't you just saying that it was waste? Well, yeah, it is. It can be a legitimate request on the part of the developers and still be waste. But nonetheless, having to do something over and over again is waste. So backlog equals waste. And the more backlog, the more waste. Another example of waste that you get out of backlog is the duplicate bug report rate tends to go up because it becomes impossible for people to keep track in their heads of what's already been reported. And so they see something and they're like, well, we try to go and crawl through the things that are open, but, do I really have time to go through 200 bugs, 200 open bug reports to figure out, is this something we've already seen? Nope, probably not. So I'm going to open a duplicate report. That's noise, and that's waste. You waste the time opening the report and the team wastes time managing the report. Eventually you find out, oh, it's a duplicate. You close it out. There is waste associated with that. You also tend to, with high bug backlog, get a higher rate of false negatives. Now, false negative, just to be clear, is when you basically miss a bug. You don't see a bug, even though, well, you don't see the failure associated with the bug because there's so much crap going on in the system and it's so buggy that you lose track of stuff. And that will tend to happen. So as the bug backlog goes up, your defect detection effectiveness will go down. Of course, defect detection effectiveness is one key to how you achieve a positive return on investment with testing. So as the defect detection effectiveness goes down, the efficiency of testing also goes down, and and again, we're looking at waste. Okay, so what do we want in terms of bug backlog? Well, first off, bug backlog is an assessment of the overall bug management process. It's not just about testing. It's also about development. It's also about prioritization and triage. So it's the whole picture. How well are we managing bugs in our software? And specifically, what we're looking at is the process of management and resolution. That can we move the bugs that we discover fairly quickly with alacrity from discovery to resolution in such a way that they don't start to queue up and introduce the kind of waste that I was describing before. Now, what we want is the backlog to be both stable and acceptable. So to start with acceptable, since I was talking about that before, I mean, this does depend on team size, but anywhere from 10, probably getting it below 10 is not realistic in most cases, and certainly not above 100, though I'm much more comfortable with 50. There shouldn't be any sign of accumulating technical debt. Now, what I mean by accumulating technical debt is bugs that are in the backlog that remain stubbornly in the backlog and nobody looks at them. They're just there, just sitting there, blah, blah. We'll get to that eventually. Look, if you're not going to get to it, then just defer the thing and say, we're not fixing this. But if it's sitting there garnering attention, then that's more waste. Now, stability. We want the bug backlog to be fairly smooth over time. Big jumps, discontinuities, that's not cool. So we saw that with the previous graph of it. There was a big discontinuity at week 4 where it took a sharp upward turn. Backlog did start getting more severe. That's not good. All right, this worksheet is just showing how this is calculated. And basically what we can do is you can see that the total reported, right? Total resolved. So the backlog is just reported minus resolved. So this column is just it's equal to this column minus this column. So pretty straightforward calculation. And then what we can do is so that you're not graphing this a data set every day, which makes that chart that you just saw look really, really busy, but instead showing weekly, then you just calculate averages for the week. So you got average reported is calculated here, average new reported, right? So that's the average based on the opened, and then average resolved, so that's the daily closed, which just really should say resolved here. And then the backlog is the average for these data sets for that week. So it's a really straightforward calculation. Excel makes it really easy. Even easier, of course, is just downloading off of our website. Okay, so closure period. So the closure period is for any given bug, you take the date on which it was opened and you subtract the date on which it was resolved, and that's the number of calendar days that the bug was in the backlog. Now, what I usually like to do is show both a daily and a cumulative number. So the daily average closure period is going to be, you add up the closure period for all the bugs closed on a given day and divide it by the number of bugs closed on that day, and that's the daily average closure period. The cumulative closure period for any given day is the total of the closure periods for all bugs closed on that day and all previous days divided by the total number of bugs closed on that day and all previous days. Again, this is something that if you like, you can filter for it by severity, and you can break it down by categories and in a tabular fashion, as I discussed before. But I like to show trends over time because, again, what I'm looking for is, in many cases, not just absolute numbers, but also trends in the numbers, particularly where they might be getting worse. Now, one thing to keep in mind about closure period is that closure period can be what's called a lagging indicator. Now, a lagging indicator is basically some sort of metric that by the time it shows you something, that something has already happened. Okay? It's basically it's lags behind the thing that is being tracked, and this can be, with closure period, a lagging indicator, and it becomes more and more of a lagging indicator when the backlog is very large. Because of course if the backlog is large, you've got a number of bugs that are sitting there, and they don't have a closure period yet because they haven't been closed, but of course for every day that they sit in the backlog, their eventual closure period goes up. So if you got a lot of bugs sitting in the backlog and then you get serious about cleaning up the Aegean stable of bugs in effect, then what can tend to happen is that you see your closure period start to go up, because it's like, oh, we're getting to all these bugs that have been sitting in the backlog for days and days. Similarly, if the average closure period is long, in other words, it's already taking a long time to fix bugs, then that makes this more of a lagging indicator, because the information you're getting on a daily basis is indeed associated with the bugs that were closed on that day, but there are a bunch of bugs that were open that day, the day before that, and so forth, that are still not yet counted in that closure period. So just something to keep in mind, that it can, as I say, be a lagging indicator, and you could be taking steps that are that have improved the bug management process, and you can be effectively carrying out those steps. The backlog could be going down, but the closure period could be going up. So here is an example, and so we've got the calendar, number of days open. Again, it's just calculated by a calendar, and then the blue is average cumulative closure period here. And what we see is it's continuing, in this case, to go up. The pluses are the average daily closure period, and as you can see, this is definitely not a happy picture, because what we're seeing is, oh wow, it's starting to just take longer and longer and longer to fix bugs. And we got off to start here, and it looked okay, kind of, sort of, to begin with, right? The 4-day was the lower bound turnaround if we're getting test releases once a week. Of course, with Agile, if you're getting them every day, it's to move this down, but the same general idea applies. But what we see here is that the pluses are consistently above the blue line, which means that over time it's taking longer and longer to fix bugs. And of course that has become exceptionally pronounced here over the last 2-3 weeks, where this has just gone shooting skyward. Now this could be, again, due to the fact that we are tackling the backlog, and as we push down the backlog and deal with the backlog, and that has brought to the fore a number of bugs that have kind of languished there. And so this can be one of those, it gets worse before it gets better scenarios. So good versus bad closure period. So again, closure period is an assessment of the overall bug management process. Does look at development, test, and prioritization. It's not just a metric of the test process. As with backlog, it's looking at bug management and resolution. Here the focus is primarily on efficiency, because it's a how long did it take, right? Before with backlog, it's how many are there, and it's not looking at any sort of issue of what it cost, how much time was consumed, how long something waited. So that's an effectiveness metric. Backlog is the closure period, because it's looking at how long in terms of days is a form of an efficiency metric. Here again, what we want with closure period is stable and acceptable. So stable, we want both the cumulative and the daily closure periods to be fairly smooth, and we want to see the daily closure period fairly close to and randomly varying around the cumulative closure period. So that's not what we saw in the previous chart. We did not see stable closure period, because what we saw was that there's considerable bouncing around in the average daily, and it's very much tends to be above, especially for the last 3 weeks. It's very much above the average cumulative, and it's having the effect of pulling the average cumulative up pretty dramatically over the last 2 months since we started to measure it. It's gone up by an entire week at least. So it's taking a week longer. And remember, the cumulative closure period is a very conservative metric, and it gets more so over time because it's looking at everything for the last for the entire project, which if there were a lot of bugs closed fairly quickly early on, it becomes difficult to pull that up. Now, one way of dealing with that is that sometimes people actually look at like a rolling 30-day average rather than a cumulative to take that conservatism, if you will, out of the metric. So stable, we didn't have stable. Do we have acceptable? Well, you want bugs to move quickly, but not too quickly from discovery to resolution. Is 10 days, 11 days acceptable? Well, I don't know. Kind of depends on the project, but that does seem like a while. You certainly don't want this to be longer than 2 or 3 times the test release interval. So, if you're getting builds once a week and it's taking more than 14 or worse yet 21 days to get bug fixes, then that's a problem. If you're getting daily builds and it's taking more than 3 days to get a bug fix, I'd say that's definitely a problem. Because what's happening is that people aren't looking at bugs when they come in. If what you're seeing is that it's 3 days on average to fix a bug, or 4 days on average to fix a bug, it's like I think they're sitting there waiting for something, and that's not good, not a good sign, because then they're going into the backlog. Yeah, and as I mentioned before, if the backlog is very large, what you will tend to see is when somebody finally gets serious about dealing with the backlog, the closure period will spike. And that is, of course, what we are seeing right here. This is the same project as here, the same hypothetical example project. So what we've seen is, as the last 3 weeks, as there's been an attempt to put the brakes on and bring the backlog down, then what you're going to see is this kind of, this kind of thing right here. See that? Backlog starting to go down. Closure period is shooting up. Okay, so how is the closure period calculated? Well, what we do is, as you would guess, we start with calculating the closure period for each individual bug. So that's what you see here in this excerpt from the spreadsheet on the left side of the screen. Then in a separate worksheet, what I have to do is go through and do a search based on date, and I look at what the closure period is. So I'm searching based on the close date, right, because that's what gives it a closure period, right? So on 10/14, this guy here, bug ID 1043, on 10/14, it's going to get picked up as part of the closure period. So this is a what's called a sum if expression in Excel, that it's adding up the closure period for bugs that were closed on 10/14. So there's one, and 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 there probably are others. It's not just 28 rows. So that's how you get your 53, right? That's the closure period for that day. And that's the first day we had bugs closed. So we have what are called inactive bugs here, which is basically resolved, bugs that are resolved. So it's going to give us an average daily closure period of 4. And of course, this is also our cumulative, so because this was the first day we had bugs closed. Now, if you look at the 15th, we picked up a bug that was closed on the 15th. That's this guy right here, 1049. So the closure period there is 7. The total closure period would now be 7 plus 53, or 60. All right. Average closure period 7. That's that, for that day there was just that one bug, right? Still at 14 now, or at 4, excuse me, for the average closure period, because the increase was not enough, but of course not enough to change the average when you round to the nearest day. But obviously it's starting to move away because that 7 days is longer than 4 days. Okay, so that's how the calculation works. Again, if you want to take a look at this, you can pull this out of our website and crawl around in the spreadsheet and figure it out. And of course, if you need help figuring out, I'm happy to help you figure it out, but I'm afraid that would indeed be consulting work, and we would need to get paid for that. The moment you go beyond downloading stuff off of our website to asking us to help you with stuff that's on our website, that converts into a consulting engagement. So just please keep that in mind. There's only so much free stuff we can do. So let me look at, I'm going to show you 3 case studies of the use of this, these metrics. So the first one, we're talking about a gaming software company. They make games. They're a big, huge company. If you know anything about games, if I mentioned their name, you would know them. We looked at 3 projects, and the test execution periods on those projects range from about 6 to 18 months. And they follow a variant of rational unified process. And if you know about rational unified process, it basically allows overlap between periods of test execution and periods of new feature development, which is true in Agile too, but in Agile development, all of the work, products, and activities associated with one iteration, including the testing work, products, and activities, are supposed to be stopped, or supposed to be done before the next iteration starts. Now, not everybody does it that way, but that's what's supposed to happen. In RUP, Rational Unified Process, specifically allows people to move on and start developing new features for a subsequent iteration, even though the features for the previous iteration have not yet been tested. And that's, I guess seemed like a good idea at the time to the rational folks who came up with it. Sorry about that. Seemed like a good idea to the rational folks who came up with it, but what generally happens when you have organizations following a rational unified process is that the backlog gets really big. And that's indeed what we saw here, is that the backlog would range anywhere from 2,000 to 5,000 bugs. And again, yeah, for real, like just visualize those orange asterisks that I showed you before, but instead of being at like 200, they were like 2,000 to 5,000. These backlogs were over sustained periods. So I'm not just talking about brief spikes in the backlog where development fell behind, but I mean for weeks on end. And of course, it would make sense the backlog would be over a sustained period of time because the average closure period on those projects was really never, except in rare, periods at the beginning and the end of the projects, never less than 20 days. And as high as 40 days, and again sustained over most of the test execution period. So the waste was enormous. We used very conservative metrics or very conservative estimates for how much waste was associated based on bugs that languished longer than a certain number of days or bug backlog over a certain size, and we were again very conservative in terms of what we said the maximum allowable closure period should be and the maximum allowable backlog should be. Even so, across the 3 projects, we found that there was at least $1.5 million in waste. And this is lost time. Basically, time spent doing silly things like, whoops, we've got to go through and remove duplicate defect reports. Whoops, we've got to have the testers go off and do a huge bugs crawl and go through all the bugs that they've reported over the last 3 or 4 months and see if they're still there. So yes, there was a lot of waste, and that does not even begin to measure the morale issues associated with it, which were, for the testing organization, significant. Now you might say, okay, well, gaming software, maybe there's something unique about gaming software. Well, no, and it's not unique to RUP either. Excuse me. Though RUP tends to have more severe problems with backlog, but here's an enterprise software company. You probably wouldn't have heard of these guys, but you have definitely been affected by their products because it's used by large organizations around the world that have probably across them in excess of 500 million customers, I would guess. So anytime those customers get a bill for their services, my client is involved in that. They build a large system of systems. There's about a dozen separate projects in there, so a dozen different components that make up this, or individual systems that make up this system of systems, and they all have to work together, and it's an 18-month total duration project. They are following an agile development life cycle in each project, 2-week iterations. This the amount of discipline that they had with respect to their agility is shown at the backlog was held well under the 1,000-ish mark, but still bug management was a problem for them because it was consistently around 250 in the bug backlog, which is too high if you ask me, and it was for 12 out of those 18 months. The closure period, this is a real measure of where the process really broke down. So within 2 months of test starting, the average closure period was 20 days. So bugs would get reported and they would just sit there. By the end of testing, the closure period was all the way up to 41 days. So it just took longer and longer and longer and longer and longer. The waste, again, we were conservative in our estimates of how much waste is associated with each bug in the backlog over a certain number, and we were conservative in our estimates of waste associated with the closure period being over a certain amount of time for a certain period of time. And we calculated, again, conservatively $2.5 million in waste per the release. So in other words, over that 18-month period, $2.5 million lost. Oh, ouch. And these are not just numbers that are just like made up and thrown against the wall. I mean, these are numbers that I extracted with the help of the senior managers in the testing organization, and which were vetted by C-level people, C-suite type of folks. It's like my final presentation with this enterprise software company. The CIO was there in the room as we were going through this, he asked some very pointed questions, but none of them getting to, well, is 2.5 million really the right number? It was more about along the lines of what the hell are we going to do about all this? Now, let's do a deeper analysis going into these metrics. I was a little bit constrained with those previous examples by non-disclosure agreements, so I couldn't actually show you numbers and charts and stuff. It was all part of my assessment report and thus confidential. But this is from a project that I did closing in on 20 years ago, an assessment that I did closing in on 20 years ago, and the non-disclosure terms have long since expired. This was a banking software project where the plan was to take this application, which was going to be used to do home equity loan packages, home equity loans, reverse mortgages, home equity lines of credit. It was going to allow the bank to transform their current system, which was a Unix mini computer, HPUX, Unix mini computer, green screen terminal type of thing, which is seen as very clunky. And this was going to use a web-based interface, and it was going to be better, they thought. And here you see what happens as we testing. I came in after the fact and did some analysis of, why did this project go wrong? And this graph shows what happened with bugs. And as you can see, the backlog shoots up to 100 almost instantly. Within 2 weeks of the project starting, we have a backlog of 100 bugs. And it never really goes much below that. It can pretty much just bounces around randomly. Sometimes, there appears to be a trend, but then bam, and then it's up, and then a little bit down, then bam, and then it's well up, and then it's kind of below, but then it comes, reverts to the 100 mark here. So really, like 90 to 100 is the typical band there. It's almost never below 50, if at all. It might have kissed 50 somewhere around here, but that'd be about it. So backlog, persistent backlog, and you can see it, right? I mean, you can just looking at this, you can go, yeah, so there's always about 100 in there, and then this is like it's going sideways here. Not a whole lot of progress on the project, and then kind of a last gasp, and this is where they said this project is dead. This parrot is deceased, and that was the end of it. And I got called in shortly after that. So I said, let me see what happened with respect to closure period. Oops. Here's closure period. Little dots here are the dailies. And this is the cumulative. The blue is the cumulative. So it started off pretty low, and then it really bounced up. And this was on a project where theoretically bugs were supposed to have a 1-day turnaround time, and as you can see, it ain't 1 day. It's up to about a week, and that's cumulative. That's including the stuff earlier when it was lower. But if you do a linear, that's the straight line here, the daily linear trend line on the daily numbers, where's the daily going? Well, up and up and up. right? Longer every week. So I do this analysis and I look at it, I go, what happened here? The thing you got to keep in mind about a trend chart, and these are trend charts that we are looking at here, and we were looking at before when I was explaining these. The thing you got to keep in mind about a trend chart is it can't tell you why something happens. It just says, here's the trend. So, and you go, why did this happen? Then you have to dig further. So, this is a big part of the problem. So, this is the affected subsystem breakdown of the defects. So in other words, where were the defects when we figured out where was the bug? You know, where did this bug live? Now the user interface. This is the presentation layer that's running on the web page itself on the client side on the browser, and also the presentation layer on the web server. If it's presentation layer problem, user interface. If it's in the app server code, the Java code in the app server, or in the queries that are running on the database server, it's loan engine. So notice that 43% are user interface problems and another 37% are loan engine problems. So between those two, the user interface and the loan engine, that's 70% of the problems. This other stuff, SOLA, this is a legacy application that was used for some part of the decision making, is 10%. The decision making mainframe, that's another 7%. The network compatibility, that was another 5% of the bugs. Deployment process, 4% of the bugs. Middleware issues, 2% of the bugs, and then everything else was another 2%. See that? So Pareto analysis. If you're not familiar with how Pareto charts work, this is something I'd encourage you to check out. But as you can see, the vast majority of the bugs were in the user interface and the loan engine, and it turned out this stuff, these problems, these are all interoperability problems associated with the system not being able to integrate properly into the data center. These were inherent. So this 30% of the bugs, or 30% of about 1,000, roughly 300 bugs, a little under 300 bugs, those were real honest-to-God bugs that did indeed have to be fixed. And notice if we go back here, we fixed way more than 300 bugs. All right, notice that the team fixed 800 bugs. So there was plenty of time to fix those 300 interoperability bugs and 500 other bugs as well. But the problem was that there weren't agreed upon requirements outside of interoperability. So all of this stuff, when you dug into these bugs, these other 500 or so bugs, though really if you look at it, so it's closer to 600, right? That's 235 plus 367. So if you look at this, you go, well, okay, these other 600 bugs, I mean, were they real bugs? Well, most of these were just differences of opinion about how people wanted the app to work. And in some cases, there would be these circular things where it'd be like, well, I'd like it to do this. And then somebody would come back and say, yeah, okay, I know I asked you to make it do that, but now I want it to do this kind of other thing. And this would go on for a while, and then sometimes that whole chain would end with, on second thought, I actually like it the way it was originally. Please change it back. So, obviously that's a huge amount of waste. Another thing that got them into a lot of trouble was this gotta fix bugs in a day. Ironically, trying to make the closure period a day ended up making the closure period longer than a day, and it ended up kicking the backlog way up. So what you can see here is a breakdown of how many times each bug in the bug tracking system was reported. So one means it was reported once, confirmation test was run when the bug was fixed, the confirmation test passed, the bug report was closed, we never saw it again. Now, if it fails the confirmation test, the tester would reopen the bug, and that increments the open count. That's what this is down here on this bottom axis, is the opened count. It's the number of times that the report was opened. It starts at 1, and each time the bug report is reopened, it's incremented. So, failed the confirmation test once, the reopen count is 2. Failed the confirmation test twice, the reopen count is 3. Failed the confirmation test 3 times, the reopen count is 4, etc. So what you can see here is, looking at this, that only 83% of the bugs were fixed the first time. Fully 1 in 6, 17% of the bugs had to go through that process more than once. That's tremendous waste. Anytime you have a bug that fails its confirmation test, as a conservative estimate, that's probably a person hour of waste. On a project of this size, which was not particularly big, we're talking about a lot of waste if, 150 or so bug reports are going through the process more than once. And it's actually worse than that, because a lot of them went through the process 2, 3, 4, in one case 10 times before ultimately getting resolved. And of course, not only is this waste in terms of person hours, but it's also schedule risk, right? This project was originally supposed to just have a 6-week test execution period. So 1, 2, 3, 4, 5, 6. That was supposed to be done here. Now, ironically enough, notice that had they had well-defined requirements for everything, not just the interoperability, they could have fixed the interoperability problems, the 250, 300 interoperability problems, plus another 100 or 150 actual problems with the system itself in that 6-week period. So the project was not by any means doomed from the start. It was simply doomed by bad decision making and a lack of requirements management and a lack of good bug management. So those two things killed the project, and led to the total outright failure of the project, and $1 million in labor costs were up in smoke on this test execution period I just showed you. Amazingly enough, $100,000, in excess of $100,000 of those labor costs were spent producing a daily project status report, which is mostly test result information that nobody looked at. The project manager, when I asked her which of those reports in the 100-page long daily packet that was being produced, which of those reports she considered to be her core dashboard reports, she said, "Oh, that damn thing, I don't look at it at all. I just throw it in the trash." Okay, so hopefully that's given you not just a theoretical insight into these two simple bug metrics, but actually practical insights into how, in 3 separate cases, problematic status with those 2 metrics put me and my client on the trail of $1 million+ in waste. In one case, of course, it was after the project was already dead and gone, but in another case, in the other 2 cases, it was pointing the way towards ongoing improvement. And, simple, right? I mean, you just need the date open and the date resolved. This is not a complex set of metrics at all. Very straightforward. If you want to get 3 more data points, the severity, the affected subsystem, and the reopen count for your bug reports, you can do more sophisticated kind of analysis, like you can do the reopen analysis that I just showed you. You can cross-reference your backlog and your closure period by subsystem, by severity, which can definitely be helpful, especially if you have some real nasty bug clusters. What you're likely to see is, for those subsystems that have the bug clusters in them, that the backlog and the closure period especially are going to be really bad. So get some data, simple data here. Get digging in that data. You want to download the spreadsheet and use it, go right ahead. Identify opportunities and get better. Okay, this concludes the presentation proper, and at this point I will answer questions from the audience. Please submit any questions you have using the webinar Q&A feature. First, a quick word about our services. As I mentioned earlier, we have a team of international consultants that deliver customized training, consulting, and expert services to companies looking to improve their test and quality assurance practices. If you receive valuable information from our free webinars, please help us continue to provide them by making RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com. Let's see, questions. I got a question from Tracy here. Can we have a copy of the presentation? It should already be posted on the RBCS website. So if you go out there and navigate to the webinars page, it'll already be out there. Let's see, Ian had a question here. Do you report on both bug backlog and closure period in a project or just one of them? And then he said, case study 2 has answered my second question. Thank you. So to that point, Ian, what I would do, what you saw in case studies 1 and 2 were analyses that were done by me as an assessment in order to look at their process capability. So that was not something that was to be regularly reported on. The graph, the open-close chart, defect open-close chart with the bug backlog shown. So in other words, something like this, or something like this, or more complex projects, would be something that I would typically consider part of the ongoing test results status reporting, and that we would track that over time. And of course, your life cycle is going to have a strong influence on what this looks like. If you're doing Agile, something like this, you know, I would hope that what we would see is at the end of each iteration that the backlog would go to 0, right, or very close to it. So you'd be having frequent convergence between the bugs reported, the total reported, and the total resolved, and the backlog, you know, dropping down to 0. With Agile, you know, you might want to graph this on more of a daily type of basis rather than weekly, because in 2-week iterations that's not going to work. But one of those two types of charts would be the kind of thing that I would tend to report on a more ongoing basis. The closure period, I would probably track that myself as a test manager, but I don't know that I would report it on a regular basis unless it got outside of targets. If it got outside of our targets, then I would say, I'm concerned now. You know, let's expose this. Guy named Ed Tufte, who wrote a number of books on how to create good graphs and charts and basically put quantitative information in front of people in a way that works for them, said that one of the questions that you should always ask yourself when you're creating a graph or a chart or table is, what do I want the person to think about? The person looking at this, what's the thinking task I want them to engage in? So, you know, don't just put information in front of people just to put information in front of people. Put information in front of people if there's something you want them to think about. Let's see. Nico says, if a bug is deferred after a number of days, should it count for the closure period calculation? Yes, it should, Nikos, and the reason being that it was it was consuming attention during that entire period of time that it was active. Now, maybe not all the time. It wasn't like somebody was laying there awake constantly going, oh my God, what about bug 6,627? I mean, that's not the way that works, but there is a mosquito-like effect for a bug being active at any given moment in time, and it's small, and it's sort of a periodic kind of thing, but you know, you get enough of them and it becomes a problem. They last long enough and it becomes a problem. So yes, there's no free passes. Ian says, bug backlog. Are the rules or guidance for severity and priority important in managing the bug backlog? I don't usually, but it might, in your organization, that might differ. So that my enterprise software client that I mentioned, for them, the numbers looked significantly different if you looked at Sev 1s versus, or Sev 1s and 2s versus everything else. And the reason for that was that they had this definition of done that was such that you basically couldn't be done unless you had 0 Sev 1s and I think it was 9 or fewer Sev 2s. And I was pretty critical of this. I said that both of those sounded like very arbitrary numbers, and you know, I would guess that people were gaming their behaviors to game those numbers, and sure enough it was. But in that case, what you would see is that for the Sev 1 and 2 bugs, that the backlog and the closure period was considerably less than overall. But you know, nonetheless, I mean, having these bugs, regardless of severity, hanging around forever and ever was a major drag on the team. Tracy says, how do we track bugs that are often pushed to subsequent sprints? Metrics-wise, it looks bad as it appears to have been sitting in an open state way too long. Well, yep. That, you know, this is the thing with technical debt. If you choose to accumulate technical debt, then metrics that look at one aspect of technical debt, which would be, you know, how many bugs do we have sitting around and how long do they tend to sit around, which is what the backlog and the closure period are. Those are definitely measures of technical debt, and if you choose to accumulate technical debt, those metrics will show that. And people just need to understand that. Now, you know, people might be saying, well, yeah, but it's a rational decision. You know, we want to push these to subsequent sprints and so forth. Well, okay. But, you know, it's like a sack of rocks. You know, any one little stone, any one little rock may not weigh a whole lot, but every time you throw a rock into the sack and you dragging the sack around behind you, eventually that sack gets really, really heavy. And that's what backlog and closure period are trying to show you is, you know, how many rocks are in your sack and how long you've been dragging that sack around. So, you know, it's that's not a bug in those metrics. That's a feature that they look bad if you just keep, you know, going, we'll get to it next sprint, we'll get to it next sprint, we'll get to it next sprint. If you're not going to fix it, just say we're not going to fix it and defer it and then take it off the list, and then that's the end of it. But have the courage to say we ain't doing that. Let's see. Tracy says, is the closure period tracked, this is a different Tracy, by the way, is the closure period tracked separately from the iteration? We include them as part of the iteration for a build, so do not track length of time they are in the backlog or the closure period. Well, okay, so my take, Tracy, if what you're saying is that you are going to track closure period in the sense of how many iterations after the iteration in which the defect was discovered was the defect around before it was finally removed, you know, then you're basically, you're tracking it rather than daily, you're tracking it on a weekly or, you know, bi-weekly or monthly period, depending on how long your iterations are. Again, you can choose to use these metrics in a lot of different ways. I'm not saying that it wouldn't work, but what what you're doing by the way that I think I hear you suggesting doing this is hiding some of the cost of dragging that technical debt around. It also sounds very much like you're not tracking bugs unless those bugs are not fixed in the current iteration, but only fixed in a subsequent iteration, which I know that some people say is a really great idea. I happen to think that's a really bad idea because you're losing visibility on an important aspect of quality and your development process overall, which is like, the number of bugs that are created and to be removed and so forth, that without insight into that, you're not going to be able to improve it. Let's see. Craig says, what I have experienced is that the backlog goes up because the developers are still coding the applications and maybe unit testing while the system testing is progressing. Then when all their work is complete, they start fixing bugs. Yep, that is classic RUP. That is classic Rational Unified Processed or classic RAD, Rapid Application Development, which is the other variant of that. Those were both 90s era iterative development processes that basically allowed that kind of, let's get system testing started while we are continuing to develop new features. And the problem with that is that when that feature development is continuing for weeks and weeks while the system testing is going on, the developers are going to say, hey, what do you want me to do? Fix bugs or write new features? And new features is always going to win. And so you're going to see the bug backlog go shooting up. And it's an invisible vampire. I mean, basically, people don't realize how much waste is associated with that. But it's almost, unless you set aside time in an iterative process for getting bug backlog down on a regular basis so that it does not get out of control, it's pretty much going to be inherent in that kind of approach. And it's going to cost the organization a boatload of money. And they're not going to be aware of that money unless they sit down, look at closure period and look at backlog and do some estimation of what excess backlog costs and what excessive closure period delays cost. And once they do that math, I promise you're going to go, oh, crap, look at that. There goes $1 million+ up in smoke. But while it's happening, it's one of these things. Many things are like this in organizations, that just literally bonfires worth of money are being incinerated in the project. And because it's something that just always goes on, people just go, oh, yeah, I guess that's the way it goes. And so they don't see it as bonfires of money being incinerated. They just go, yeah, that's the way, that's how projects work. We're heating the house. No, you're burning money. You're losing money on stuff you don't have to lose money on because your process sucks. Your process is inefficient. And that's something that I try to do in these assessments, is go, look, you've got waste, and it is amazing amounts of waste. So just because people look at it and they don't freak out, it's just because you haven't brought it to their attention in the right way. If you bring it to their attention in terms of here's $1 million per year going up in smoke, you will get people's attention with that. Nico says, in many projects, the cost is quantified in man days or person days, if we want to be more politically correct. Maybe instead of expressing the cost in dollars due to closure period, man days, person days could also be used. Sure. Yeah, if you prefer to do it that way, if you think that's going to be less controversial and it will still get people's attention, fine. Now, I didn't have any access to specific people's salary information in order to come up with those numbers that I showed before. I didn't need it. You don't need it. You can find on the internet what the average cost of a developer hour is, or a developer day, or a developer month, or tester month, or an architect month. You can figure out what those costs are really easily on the internet without anybody's private information being divulged. And personally, what I have found is that dollars, pounds, euros, those kinds of units get people's attention a little bit better than person days, my experience. Yours may be different. Ibrahim says, is product backlog and bug backlog the same? Sometimes bugs with enhancement are maintained as product backlog. Thanks in advance. No, that's not the same. Product backlog is a Scrum term that refers to user stories that we're waiting to fix. And that's not a problem. User stories get queued up in backlog and they sit there and they don't consume any effort until they get pulled off the product backlog into the sprint backlog, and then that's the point where you're going to start working on them. And the product backlog is just a queue, a repository for holding stuff that's waiting for attention. Bug reports represent actual defects in the software itself, which are often, usually, expressed as unacceptable behavior of the software itself, which is going to have a real impact on your ability to carry out your project. Philip asks, are there other metrics that you consider critical for a QA team to always track? Yeah, I mean, I think I've done some other presentations on metrics and results reporting, so you can kind of crawl around in my recorded webinars. Now, here's a thing: is that this happened to me earlier this week. I did a metrics workshop, and I think there was some folks were kind of like wanting to go, well, what should my dashboard look like? What should my test results dashboard look like? And I think that's what I hear you asking here. I can't answer that question. Here's the thing with metrics is that all too often people start with the metrics. They're like, oh, look, I've got metrics. To which I say, so what? Not so what like mean, so what, but so what? Like, okay, for each one of those metrics, please explain to me how that metric relates to a strategic or tactical objective for your project or organization. Yeah, in a short sentence, please. And usually what that results in is somebody who looks kind of like a fish that's just been pulled out of a lake or an ocean. They're just kind of, the mouth is moving, and the gills are flapping, but there's not much coming out because that's not how they got to the metric. If you do not derive your metrics from strategic and or tactical objectives that you are trying to achieve in a project or in an organization, then the import, the consequence, the meaning of the metric is unclear. What to do with it is unclear. The decision-making associated with it is unclear. So, don't just go, what is the magic set of metrics for my dashboard, because that's starting with the wrong question. Eva, I could possibly pronounce your last name, Eva. I usually don't, but I'm guessing that's either Czech or Polish. It's a beautiful name. Says, can you please spell Ed Tufty? And you spell it Tufty. You're saying I'm not able to find his work on Amazon. Tufty, Tufte. Edward Tufty. That should help you. His best book, in my opinion, it was the first one I read, and it was a real eye-opener, is called The Visual Display of Quantitative Information, I think. And while that is a dry title, it is a book that will really, if you're a metrics person like I am, you're a big believer in quantitative data, and quantitative data is the root of all real knowledge and understanding, then that book will open your eyes in a very long-lasting way. I found it a tremendously useful book. Ian says, thanks again for your answers. Very much appreciated. You're welcome, Ian. Sinisa says, how to easily calculate value lost in dollars in correlation with size of backlog and closure period. Great presentation. I really enjoyed it. Well, basically what you need to do, Sinisa, is be able to come up with a number of person hours of waste that is associated with a bug backlog over a certain amount. And so in the case study, the gaming case study that I mentioned, I said that above 100 bugs in the backlog, that there would be a certain number of person hours of waste every month when the bug backlog was above that. And I came up with that number based on some conversations with the managers, and we kept it very conservative. So it was always like, so we can say it's at least this number of person hours, right? And then I went off and I did some research of what is a person hour of tester time and developer time in that particular location cost, and that's where the number came from. And it's basically the same kind of thing with closure period. This, you know, if it sits there for over a certain amount of time, what tends to be the cost associated with that? So talk to people, come up with some numbers in terms of person hours, and then do some web research, and you'll figure out how many dollars that is. Tracy, I have two Tracys here. So one of the Tracys, the Tracy with an E in Tracy, said, I agree 100%. I'm not sure, since that was 15 minutes ago, what exactly you're agreeing with, Tracy, but I'm very happy to hear that I said something you agree with. The other Tracy, again, referring to something I said about 10 minutes ago, says, yes, that is exactly what happened. I think this webinar will help us improve our process and tracking. Again, Tracy, without the E, I'm not sure what exactly I said 10 minutes ago that was exactly what happened, but I'm glad I was able to hit the nail precisely on the head 10 minutes ago, and that this webinar will help you improve your process capabilities and your tracking. So I think this has to do with, I think we were talking about not tracking bugs during the sprints, but only tracking bugs that carry over from one sprint to another, and that was provoked one of my usual, semi-Tourette's episodes about not recording bugs when they're found. Eva has clarified the origin of her name, which is Polish. I'm not going to try to pronounce it because I know I would screw it up. It is a beautiful name. So I assume that you are you in Poland, Eva? Is that where you're listening to us from? If so, oh, you're in India. Eva says she's in India. Okay, well, so Polish Eva in India, thank you for your participation. Thanks for getting up at whatever ungodly hour it is in India to listen in, and hope it's been a good use of your time. Eva says, thank you, it's 1 a.m. Wow, that's late. I've kept you up quite late. I hope this has been a useful way of spending time. It's Friday night, Saturday morning there, so hope I haven't been keeping you from doing something more entertaining. It's well worth it. Eva says, thank you. You're quite welcome. Carol says, as always, 100% of what you present focuses me on doing the right thing. Well, that is really good to hear. I am glad I am not sending anybody off on pointless errands and silly pursuits. So practicality is what we focus on here. Is, can we help our clients test better and develop better software? So I'm glad to hear that we're hitting the target for you guys. Okay, so some good questions. Thank you guys for your participation. To close this session, remember that we run these free webinars once a month, so go to rbcs-us.com to sign up. While you're there, sign up for our regular free newsletter to get valuable discounts on consulting and training services, and a regular newsletter. It includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can also follow us on Twitter. As you see here, our main corporate account is at RBCS, and for SDETs, we also now have at Mr. SDET. On Facebook, we are at Testing Improved by RBCS, as you see below. We have my LinkedIn account there, Rex-Black, and our YouTube channel, RBCS Inc. Previous and current recorded webinars are posted regularly on the YouTube channel and also on our social media, so keep an eye out there. Like if somebody missed this webinar that really should have heard it, it's going to be recorded and posted within the next week. You can also check out my blog. That's rbcs-us.com/blog. If you want to make a comment, when I make a blog post, I cross-post that onto our RBCS Facebook page, so you can comment on our Facebook page. We offer these free resources as a service to the software testing community because at RBCS we are a not just for profit company. Don't forget, we also need to keep the lights on, so please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. This concludes the webinar. Thanks to everyone for joining us today, and look forward to seeing you for subsequent webinars.